13.5 area under the curve we'll discuss. Now I'm going to show that finally ax, a, the function of x, the x-axis is going to be y dx or fx dx. So this is the target. It means this whole curve is up from here to here, y dx. Okay, I will take this value x naught. So this is x naught, y naught. Now I will increase this area by delta A, and I will take this distance as delta x. Small x distance, we shift this boundary to up to here. As a result, we are getting delta A, this area, and this distance is delta x. Now we will find the area. I will put this as A, B. I'll complete a rectangle C, and this point is D and E. So this, so I consider this part, and this one A, B, C, D, E, and one more from here. This is F. F. A, this point is X. Now what you can tell about this area, A, B, C, D area. So you can tell that, you can see that A, B, C, D area A, B, C, D is less than the delta E. What is the delta E? Full curve under this curve part. And then this area is smaller than this whole bit. So A, B, E, F. I break this into two small rectangle and a bigger one. I consider A, B, C, D area. Then I consider the area under this curve, which is delta E. And then I consider bigger rectangle A, B, E, F. So what is the height of this one? This is delta x. This distance is y naught. Okay, I will write first of all area and area A, B, E, F. Oh, this is an inequality with the area. Now we'll find the area. Area of A, B, C, D. So this is going to be delta x times y naught, because rectangular length multiplied by width, and delta is as it is because that is the area. Now we want to find the area of the bigger triangle A, B, E, F. So I have the width, that is delta x, and the length is y naught. Okay, this side is missing. I will take this is t. So delta x y naught plus t. This side is t. Now I am going to divide this expression by delta x, because delta x greater than 0, then you will get y naught delta a over delta x, and this is cancel out y naught plus t. Now we have issue. We want to cover, we want to find the area under this curve. And we only have the data, the small rectangle area, and we have again the big rectangular area, but we need the area under curve. Now this is a error. There is, now how can I minimize this error? Rather than error, it is not accurate. How can I increase the accuracy of this one? We can do that by taking delta x smaller. I'll bring delta x up to this one. So this is the new delta x. Then this is the new small triangle, and this is the bigger triangle. Right now this accuracy is increasing now. The difference is decreasing. There was a big difference in the bigger from here to here, but now that difference is decreasing. So I realize if I further bring in delta x to smaller, so then this is the new delta x. And likewise, what I am doing, I am taking delta x towards 0. I am taking the limit, I am making delta x tends towards a 0. So then I apply that mathematically. Take limit delta x goes to 0, y naught. Limit delta x goes to 0, dA over delta x, delta A over delta x. And limit delta x goes to 0, y naught plus t. Now you can see that this y naught is not influencing on delta x. So it is has to be y naught. Now we'll leave this one, limit delta x over, okay, what is this one? Limit delta x goes to 0, dA over delta A over delta x mean this is dA over dx. And now delta x goes to 0, what will happen to the t? This is this t, and now this is new t, new t. So t is become smaller. So, and when it's come to delta x becomes 0, t also becomes 0. Then this answer is going to be y naught. So we want to write as delta x goes to 0, t goes to 0, that's why. Now you end up with this one. Now what is the conclusion? If we have something like that, 3 greater than uh, let's say m greater than n, less than n. What is, 3? 3 less than m, and m less than 3. So what is the conclusion? What is, so 3 has to, m has to be greater than 3, and also m has to be less than 3. So what is your conclusion? Your conclusion should be m equal 3. There is no other possibility exist. So we have to apply that to here. Now Final conclusion is dA over dx is y naught. Now this is for a particular point. So we'll get to a general point. This is dA over dx equal y. Okay, I stay with this y naught. And now I need to find a area, not so then I'm going to integrate this one. dA over dx times dx is y naught dx. I put integration sign to both sides, then dx to both sides. So this will become a and y naught dx. So this is dA over dx times dx equal y naught dx. It means a equal y naught dx. Now, what is the meaning of this one? This a mean, this area mean, um, how do you find? We have to integrate from origin up to y naught, up to x naught. But give the right idea, I will come to a general version now. So this is a, and this is instead of y naught, I will take y dx. Now it is more meaningful. In general, y mean any place of the standard curve, y equal fx, and y is the height for any place, any given place. In that case, it is up to x naught. Um, Now, what is the meaning of that? So this means that from origin up to x naught, from origin up to x naught, when you integrate this area, so you will get a. Or in the simple version, when you integrate this one, and when you submit this, when you evaluate this area, when you submit this limit, then you can get the area. Now, for example, right now, instead of y, I am going to introduce origin to x naught and fx, because this is y equal fx curve. Now, I will take origin value is something like p, okay, or alpha. Now I evaluate this one. A equal f x naught minus f alpha. I have to use this is for the simplest for capital, because it's going to be a cumulative. To understand, I will do like this. So when you integrate fx, you will get fx, and this is alpha to x naught. I think now it is more meaningful. Now when you evaluate this one, a equal f x naught minus f alpha. Assume that this is fx, and I will explain a bit. So assume fx is x square. Then when you integrate this one, you will get x 3 over 3. So that is different function. So I will take that as fx. Now this one we found out up to x naught. So this a is up to x naught. Assume that You want to find up to A, simply. I will tell that up to this whole area is A1 now. So A1 equal if, what is the X naught? Instead of X naught, now you have to put A. If A minus F alpha, origin is going to be the same from somewhere else. Right? Now, assume that I want to find out area up to B, this whole area. Let's say area up to B from, so then area up to A, area up to B. Then this is become A2. I will take that area is A2 now, the new area up to here A, up to here A1, up to all area A2. So that is going to be F B, because this point is B, minus F alpha. Assume now I want to find this area in between. Let's say B, this area I want to find. A to B area. That area I will call B. So B you can find up to whole area A2 minus A1. So up to whole area you can find B, you can find A2 minus A1. What is A2 mean? FB minus F alpha minus A1 mean what? FA minus F alpha. Now I'll simplify this one. FB minus F alpha minus FA plus F alpha. Now this plus and minus F alpha cancel out. And this is FB minus FA. Then can you put back to the limit again? So we come from the limit and we evaluate the limits, and now we are here, and shall we put back to the limit? What is this one? Fx a to b dx. Assume if you have a to b fx dx, if I ask you to evaluate, so you will write fx a to b. It means fb minus fa. Right? So you have this one now. Then you have to write. Okay, I will go to that one. Then it is more meaningful. Fx a to b. It means a to b fx dx. So this is equal to b. So b. It means if we need to find this area, simply what you need to do in general, in simple, you we have to do, we take the function and we have to integrate this one. Then after that we want to apply the limit a to b. That's all. So this is the b area. We'll discuss one example. Sometime the whatever my discussion you may understand, sometime totally 0% understanding, no, in between 70 to 80. That's fine. If you can't understand this one, that is enough, right? So I will consider y equal x square. So I draw the x square curve now. Right? So what is area under curve, not above. right? Area under curve for this formula. Above also we have different one, right? Now I want to find area under this one, right? A to B. So what is this one? Y equal x square. So um, or fx. Y equal fx equal x square. Now this area, I will take, okay, B, this area. B is A to B, fx. Now what is fx mean? X square dx. Then x cube over 3, uh, A to B. It means B cube minus 3 minus A cube minus 3. We'll put a number to here. So 3 to 4, you want to find the area under this curve. Then this is going to be, this is the standard formula here. So B equal x square y or fx dx y dx. This is usually right. You can't see that. B equal y dx A to B. So this is fx, and if I need 3 to 4, this is 3 to 4. Then we evaluate. So if I need to get y equal fx equal x square curve, find this area. Simply x square dx 3 to 4. This area is B. That's all. So x cube over 3 is 3 to 4. So 4 cube over 3 minus 3 cube over 3. 16 over 3 minus 9 over 3, which is 7 over 3. This is the area. This is has to be square units.